In this example, we will demonstrate how to interface a switch. We will define a variable. Then we will show how to write software that inputs from that switch, and we will use the AND function to mask or select individual bits. Let's begin. In this example, there is a switch, and the overall goal is to set a variable in the software true if this switch is pressed. True will be defined as any non-zero value, and false is defined as a 0. The first goal is to interface the switch. What do we have to work with? The switch is a mechanical device such that if you push the button, there's zero resistance across these two terminals. And if you don't push the button, there's infinite resistance. In order to create a voltage out of this position, we're going to need a resistor, the power supply, and ground. There are two ways we could connect it. We could put the resistor up here, the +5 up here, and the ground down here, and create a negative logic switch that looks like this. With a negative logic switch, when the switch is not pressed as it's shown like here, the voltage is +5. And when the switch is pressed, as shown here, the voltage is 0. Again, the negative logic switch is such that when I press the switch, I get a 0 value. The other place I could have put the resistor is on the bottom of the switch or below the switch. If I put the resistor down here and connect +5 to the other end, now I have a positive logic switch. A positive logic switch looks like this. Now, when the switch is not pressed, as it's shown here, this resistor pulls the output down to ground, or 0 volts. But when I press the switch, the resistance between the two terminals is 0, and therefore the output becomes +5. So, in summary, a positive logic switch has a logic high when the switch is pressed. We will use this one for our circuit. In this system, we'll need a variable. We'll call it pressed, and we'll place it in RAM. In order to get data into the computer, we're going to need an input port. An input port is a wire external to the microcontroller, allowing data to enter or flow into the device. We're going to use PT0, but we really could have used any of the pins on the 9S12. We will connect our positive logic switch interface to port T bit 0. Notice that when the switch is not pressed, the input is a logic low. But when the switch is pressed, 0 resistance between the terminals of the switch will cause the input on PT0 to be high. This bit, whether high or low, will show up in port PTT into bit 0 right here. We are done with the hardware. Now it's time to write the software. We begin by creating a variable. The org statement places the variable pressed into the RAM located at 800. The reserve multiple bytes 1 will reserve 1 byte for this variable. Again, it's a Boolean variable, having the value 0 if false, and having any non-zero value will mean true. In order for this pin to be an input, our initialization program, or our ritual, will need to clear bit 0 of the data direction register for port T. To do this in a friendly way, we saw last time if we bring the value into register A and it with a mask such that the desired bit is 0 and store it back, this will clear bit 0 of DDRT, causing PT0 to be an input. Again, this ritual will be executed once at the beginning of our program. Well, how do we input from a port? Actually, it's quite easy. Since the port exists at a specific address, in this case 0240, to read the value of this port, all we have to do is execute the load instruction, or in this case load A, using the address of port TTT. The action of this executing instruction is to bring the value that exists in port T into register A. The load A instruction brings all 8 bits of port T into register A. In this example, we're only interested in bit 0. So, how do we look at just bit 0? The AND operation is such that the output is a 1 if and only if both inputs are a 1. We can use the AND operation to select individual bits. For example, if we want to select bit 0, if we AND it with a 1, bit 0 and 1 will be bit 0. But the other bits we're not interested in. The other bits where I equals 1 through 7, we're going to AND with a 0, and this will cause those bits to become 0. Let's see how to do that in software. In software, we use the AND instruction to AND. When we have the pound sign, that means we're going to AND with a constant value. In this case, $01, shown in binary as 000000001. Notice we place the 1 in the position where we want to select or mask the bits of interest. And when we AND register A with the constant $01, what we're left with is all zeros except the bit we're interested in. And so the value in register A now contains a Boolean or a logical value representing the switch. Again, if the switch were pressed, this would have been 5 volts, A0 would have been 1, and now register A would equal 1. But if the switch were not pressed, this input would have been 0 volts, binary value A0 would have been 0, and register A would be 0. In other words, register A is 1 if and only if the switch were pressed. This is exactly what we need. So the last step is to take the value that we temporarily calculated in register A and store it into the global variable here in RAM called pressed. And we use the store instruction with extended addressing to do that. So in summary, we saw how to interface a switch. We used the resistor here and the plus and ground to create a voltage. In this case is true or high when the switch is pressed. And this voltage is low or false when the switch is not pressed. We created a variable here called pressed, and we place it into RAM. This variable is a Boolean, such that it will be non-zero if true, and 0 if false. To create an input device, we had to clear the corresponding bit in the data direction register, shown here in the ritual as a load and store. To read the value of the bit at some time later in the program, all we had to do was load A with the address PTT, and that brought in the value that existed at the time of that execution into port T called PTT. And lastly, we saw how to use the AND instruction to mask or select individual bits. In this particular case, we were interested in bit 0, so we masked or ANDed the value in register A with a 01, which selected just bit 0 and stored that in our variable called pressed.